Hello everyone, welcome to Timesheet is Data Science. It's a timesheet is data related video series, and I'm hoping to release quite a few of them focusing on some basics to advanced timesheet is data analysis, visualization, and forecasting. So in today's video, I'm going to talk about 6 essential plots for time series data analysis. I have written a blog about these plots in Towards Data Science, a Medium publication. I will be putting the link towards the end of the talk. So let's dive in. So the first plot is a simple time series plot. This is what you get as a default plotting when you just plot the values against time. So on the x-axis you have years, and in the y-axis you have the observations. In this case, number of new family houses sold in 1,000 units in different years. It's a simple plot, yet I think you can still get a lot of information out of this time series plot. Some of the very basic things you can find in this plot is the trend. There is some seasonality, and also around 2005, as you can see, there is a break in the trend. So these are some of the basic information you can extract. But as you can see, um, uh, this time series data is very noisy. I mean, you kind of see some of the information, but there's a lot of information also hiding behind this noise. So the in the next few slides we will be cleaning up some of the information and filtering out some of the noise to see to zoom in and see we can get more information out of the time series data. So the second plot, when we remove the seasonality, like I said, here is a seasonality. So if we remove the seasonality, then the data becomes quite a bit clean, and here you get a better sense of the trend. For example, the house units sold were kind of flat uh, between the years 1970 or even before that until 1990, and then it just skyrocketed until 2005, and then this is what happened around 2007, 8, 9 housing crash, and again in around 2011 the market started to recover. Yet up until 2018, as you can see, this market has not fully recovered, still at the level of, like, 1970s, way behind the peak of housing house sales. So like I said in the beginning, you get this better picture of the trend at the expense of some information, which is the seasonality. So the next plot number 3, is we got rid of the trend. We were not interested in trend anymore, but we are interested in the seasonality, or in which months the housing sales are the highest and which months are kind of flat housing sales months. So each um, of the lines here represent 1 year. For example, 2005, 2004, 2000C, and there's a lot of overlaps here. So it goes on and on in the past. So what are the information that we are getting from here is that, as you can see, in around March and April, the house sales are the highest, and it goes down a little bit in the summertime, and from the fall it really flattens, and November, December, January is basically flattest of time for housing sales. So the next plot is called the sub-seasonal plot. You got kind of similar information like the previous seasonal plot, but in a different way. maybe you got a little bit more information from here than the seasonal plots alone. For example, here the horizontal bars represent the mean housing units sold in every month, and these variations are for each year in this particular month. What are the variations over the years since 1970s, for example, to 2018? As you can see, in at least one year in February, the housing sales went down around 25 to 30,000 units, and at least one year, which year we don't know, we can tell from this plot, but we know that at least one year, in one year, the housing number of housing units sold was above 100,000 units. So yeah, so this tells you the um, seasonal mean, as well as some variation around the mean in different years. So number five plot is timesheet is decomposition, and as the name suggests, it is a decomposition of the timesheet. Is that means you all the plots that I talked about, the previous four plots, you could basically plot them all and see them all in one plots in this decomposition. So what you get is the first plot in this decomposed timesheet is the original data, no change in anything. And the second subplot is the seasonality. So if you extract the seasonality from this data, then this is what the seasonality look like. And as you can see, the seasonality is very strong, and there is quite there's it's uniform basically. The third subplot is a trend, which again, as I mentioned, is it shows the overall trend and what happened around the housing crisis and so on. The final plot, which I have not talked about yet, is it's called a noise. So this is your original plot. When you subtract the seasonality, you get this plot. When you even got ridden of the seasonality and trend from your main data, what remains is this, the remainder, or random data, or noise, as I call it. The final plot I'm going to talk about is the autocorrelation plot, and it's not very intuitive, it's not very easy to understand, but it's a very important plot in an advanced time series data analysis and forecasting. Specifically, if you want to forecast time series data using advanced methods such as ARIMA or exponential smoothing unit, to understand the autocorrelation. What does it say is that autocorrelation, every year sale in our data, the sale of housing units in every year is dependent on previous year sales. What is the importance of this plot is that you could use this as a parameter in your advanced forecasting applications. So, like I said, all these six plots I've written about them in a blog in Towards Data Science. If you just Google the title of this, you should be able to find it. Yeah, I'm really hoping that it is very useful for you, and I'm really looking forward to talking about some other things about time series data analysis, forecasting, visualization. I hope you'll be sticking around and be with me, and see you next time then. Bye.